Okay, so very similar to this is, but different, is product notation. So this is a multiplication. We're taking the product of a sequence of things. Okay, so now this time, if we have a sequence of numbers, x1, x2, x3, all the way up to xn. So if I want to take the product of all of those, x1 times x2 times x3 times all the way up to xn, it's it's messy, right? If there are a lot of them to write this out. And so a notation has come together to represent that, and that is this thing that looks like a giant pie. And so we're letting I run from 1 to n, xi, and that's the definition. So now that we see that, we think, well, wait, but I'm letting I run from 1 to n, but that's loops again. And so if I want to model this with a computer, which we do a lot, I'm going to go back to loops. And so it looks very similar to what we did. The only difference is that this time, instead of adding that next element, I'm multiplying. Okay, um, and I have examples on the next page, so we can go through what that looks like. So if I want to take the product of I times I times I times I, where I runs from 1 to 4, so I want the product of 1 times 2 times 3 times 4. That I can write out, but what if I wanted the product of 1 to 100? Well, that gets a bit more cumbersome to denote. Okay, so the way that I would do that is I would write exactly this. And this is the same as having written out by hand 1 times 2 times 3 times 4, which is equal to 24. Likewise, I can let I run from 1 to 3 and add up the squares. So in this case, I'm multiplying, or sorry, so the product from I equals 1 to 3 is going to be 1 squared times 2 squared times 3 squared, which is the same as 1 times 4 times 9, or 36. So what is this? And what is this asking you to do? So this one's for you to figure out. Yeah, so I see there's a few different answers. Exactly. So the one thing that I did put in there to kind of not try to trick you, but make sure that you caught on to is that I started from 0. Okay, and so that means I'm going to let I, okay, so I can think about, well, what is I running from? I is going to go from 0, 1, 2, all the way up to 3. I is going to run all of those. So I see that there are a few correct answers. So when I equals 0, well, what is this equal to? Oh, it's 2. Okay. And then I'm going to take the product of that. When I equals 1, what is that equal to? Oh boy, I should have used a dot. 2. And then the product of that, next, when I equals 2, it's still 2, right? And the next one is still 2. And I think that's, so that was I equals 0, I equals 1, I equals 2, I equals 3. So it doesn't always have to involve the variable in question. Sometimes we use that index and then we disregard the index completely. And this is true in programming as well. That index variable that we use to loop through things, that is not always what we care to be manipulating, right? Maybe we just want a power of 2. And so this is 2 times 2 times 2 times 2. And if I carried on, I would get that. So somebody can tell me, well, what would that give? If I was letting it run from 0 to n, what am I actually getting back every time? So whoever said 8 was correct. No, 16, sorry. 2 times 2 is 4 times, yeah, sorry. Why are they all 2? It's because the thing that we want to, so if I take a sum or a product, it doesn't matter which, the index I, the piece that goes here that I'm actually going to multiply is what determines what it carries over. So I'm letting I run from 0 to 3, but what I'm evaluating when I equals 0, 1, 2, and 3 is whatever is held. I'm going to change the color of that because I have a lot going on. Um, what is evaluated is whatever is held here. Well, 2 is always 2, no matter what I is equal to. So when I equals 0, 2 equals 2. When I equals 1, we still get 2. When I equals 2, we still get 2. And when I equals 3, we still get 3. We're still allowing to carry on changing the I, but that value never changes. And so what determines what you're multiplying is what comes after that product notation symbol. Okay, does that make sense? The same is true with that summation notation. What decides, like if I go back here, um, what decides what we're adding is what takes place right here. So if I chose, and I think I did that more here, if I choose to use I, that's great. But what if I go back to this slide, what if I say I let I run from, again, we'll say 0 to 3. And instead of giving anything revolving around I, what if I say I want the sum of 2 for I equals 0 to 3? Well, this time I still let I go from 0 to 3, but I look at what that would be for each value of I. So it's 2 when I equals 0. Well, that's 2, right? Plus, yeah, does that make sense? Plus 2, plus 2, plus 2. And that gives us the 8, I guess.